Hello everyone, welcome to ScareCrow detection of ScareCrow EDR Bypass payloads. Today we will discuss EDR, the ScareCrow framework, and methods to detect EDR bypass. I am Brian Payne. I'm a technical manager with Optiv's threat management practice. I've worked various roles in information technology and information security over the past 25 years, and most of that effort in the last 7 to 8 has been related to incident response and digital forensics. So what is EDR, or Endpoint Detection and Response? So EDR is a tooling or a capability within our environments that lets us look into process data and telemetry of a system. The detection piece means that we can see things like suspicious activity based on how processes interact with the system, or different things that they're maybe doing on the network. And then moving into response is our capability to actually investigate and dig in and see, can I figure out what process A is doing to process B? And is this something that's normal, or is it something that we're going to consider as malicious? So companies like VMware Carbon Black with their Carbon Black Cloud product, or CrowdStrike Falcon, they've extended these capabilities beyond even the detection and response side to actually include some defense capabilities as well. Things like Next-Gen AV for cleaning up malicious files, potentially stopping process execution, and also isolating systems from the network. So all of these capabilities, we have come to rely on these tools. And as such, they've become trusted. So what do we do, or what happens if some technology comes about that maybe messes that up for us? One thing that can mess EDR up for us is a technique known as EDR bypass. The technique is meant to disable telemetry collection for a period of time, to prevent us from seeing maybe the malicious activities that a payload is performing once the EDR has been bypassed. One such tooling was put together by Matthew Eidelberg from Optiv on our attack and penetration team within threat management. His tool actually is a payload generation framework. He goes into a lot more detail in his talk during SourceZeroCon, named Remaining Invisible in the Age of EDR, so please check that out. So how does ScareCrow work? ScareCrow is, as a framework and generating loaders, it will first create that loader from a bit of shell code and some other magic that Matthew's put in there. But basically, we're creating something that can be loaded that then kicks off the capability for, performing the EDR bypass. That's done through fleshing the hooks that are related to system DLLs in the process memory of that loader. Once that's flushed and everything appears okay, it then executes the payload or our shell code or malicious code that we've put together. So even before the stage regarding EDR bypass, ScareCrow actually has multiple techniques that are used for hiding to make sure that it's not caught as it's delivered. That might include things like property strings within the binary, things that make it look like it's a standard Microsoft executable. So in some of the examples in the slides, you'll see PowerPoint.exe. So some of those strings match what you would see with PowerPoint, original file name, the manufacturer being Microsoft, and so on. Additionally, there's some realistic code signing, so the tooling will actually go grab certificates from sites to kind of match the data that's put in those, and then also the naming of the file itself, and some other techniques as well. Again, if you want more detail into that, make sure you check out Matthew's talk. In case anyone thinks that they now need to throw out their EDR because the sky's falling and this technique's kind of, totally fix it for the attackers and we can't ever see this again in the EDR. Let's talk about that. Is there a way we can see this in the EDR still, or see something related to the attack? And the answer is potentially, right? Or maybe. Sometimes attackers are very noisy in the attack. So we may get to see things leading up to the deployment of the code that then uses this EDR bypass technique. Maybe that's the initial stages of maybe deploying a phishing email and document that then executes PowerShell, and maybe all of these other things are going to get detected by the EDR, and we can see it leading up to that point where we've got the EDR bypass. So we've got that side of things. On the other side of it, we have the shell code that is actually loaded into the EDR bypass loader. That shell code may be something that's very recognizable, right? Maybe it's Meterpreter, maybe it's something to do with something like Mimikatz, in which case, those other capabilities or even, Cobalt Strike calling Mimikatz or Meterpreter calling Mimikatz, those techniques are well documented and discoverable by the EDR. So anything before and after is potentially still discoverable, even though that specific binary or that loader payload is actually performing the EDR bypass. So we're still, potentially going to see something in the EDR. So another way we may see this in the EDR is when someone's generating a binary payload. So something like the executable, the DLL, the control panel applet. We may see those getting written to disk as part of this process, right? So at some point, we would generally expect, especially an executable, to be executed. It's kind of the whole point, right? That there's a process there that runs it. So if we're seeing data in the EDR that indicates an execution, then that by itself is interesting, right? I mean, obviously, yes, we're tracking thousands upon millions of executions all the time or new processes. But what is interesting about this is it's likely to be a binary that has low prevalence in the environment. Obviously, going to be low prevalence in the system, in its history of process activity. It's going to be low prevalence, most likely, with other executions of similar binaries in the environment. And then obviously, moreover, on those EDRs that track it on a more global scale, you may see something like it saying that it's low prevalence in general. Another thing to consider with binary payloads is where they're being written to on disk. We wouldn't normally expect to see something like PowerPoint.exe running from a user's desktop directory or command.exe running from ctemp. So obviously, watching out for that information can help us to identify maybe some of these attacks where the adversary maybe isn't paying as much attention to which binary that they're distributing and maybe not using the best tradecraft. So along those lines, I mean, we can look in the EDR and search for information around the prevalence of those locations. We can very easily craft something like a search on PowerPoint.exe and then review the path for that, or maybe the full image name. The other piece to consider is, not only the location on disk, but what type of server is it? So which location of endpoint? If we're not normally running PowerPoint on a server, should we ever see it on that system? So something to keep an eye out for. In EDR platforms that provide some more detail around the executables themselves, such as Carbon Black, some of those may show an invalid certificate signing chain, something else that we can potentially look for later on disk. Other tools like CrowdStrike, where maybe we've got the benefit of next-gen AV or something like Overwatch within their product, it may also hit on AV. So something just to kind of watch out for, that some of these things may have become signatured within different products, or different behaviors may start to become detected over time. It's just part of that constant cat and mouse game that adversaries or attack tools have to keep up with, just as the EDR tools need to keep up with a technique like this. My coworker Ryan Boyle has provided the following query to assist in searching for binaries masquerading as standard Microsoft binaries. The query looks for anything that's a console-based application that is signed by Microsoft, but where the certificate chain is not verified. Finally, with EDR, one thing we need to consider is the side effect of performing the EDR bypass. The common aphorism of absence of evidence is not evidence of absence may apply here. Specifically, normally when we look in our EDR systems and we look at a specific process, we expect to see additional activity afterwards, whether that's file writes or registry writes and DLLs being loaded and whatnot. What happens is we stop seeing that data. So that by itself may be of interest to us. Very rarely do we have applications that aren't doing something else on the system. With that, what may be helpful then is comparing that against our other systems and where we're about to dig into on things like the SIM or disk forensics or memory forensics or network, and just seeing if I have network activity to a host, but it's not showing up in my EDR. That's kind of interesting. So maybe we need to have different queries set up, whether that's in our SIM or EDR, and maybe some outside tools to then compare that data. As we move from EDR into other areas of forensics, one thing we might want to consider is Yara. We've developed a Yara signature for the first version of ScareCrow. It's a very basic detection. This can actually cross over between our EDR, our memory forensics, AV, and disk forensics. So it's something that's good to look at. One thing to point out within that Yara signature online is the lines relating to the Go build ID and Go.build ID terms. Those items are interesting because we don't normally see those compiled Go code items frequently in standard corporate environments. But there are many attack and security testing tools that do contain that line. So you might be able to set up alerts in your EDR system for files containing those strings. The way the signature is written may not work in various tools depending on which version of Yara you have compiled into your tools. So especially the line items referring to like the PE version info file description field. But you can redo those to be standard string searches so that you can identify items that match. After our EDR capabilities and Yara signatures and scanners, we should also consider antivirus. The binary payloads generated by ScareCrow, at least in the first version of ScareCrow, there's a base 64 encoded string that causes them to be detected by Windows Defender. This, and depending on what shellcode has been loaded, and activities that the adversary may perform in the shellcode that they've loaded through the EDR bypass, it may still be detected by something like Windows Defender, especially if there are common signatures out there or if they're using something like Meterpreter, where many AV companies have developed their signatures over time and thoroughly understand the process of how that shellcode works. So definitely something to keep an eye out for and make sure those tools are up to date all the time. On the other side of it, the signatures can always be toyed with. It takes very minor modifications to code. In fact, the new version of ScareCrow, Matthew is changing and or removing the string so that Windows Defender will not be detecting ScareCrow loaders in the same way. So given enough time and enough payloads having been generated, though, more signatures will be created by the AV vendors and EDR companies. So those loaders are more likely to be detected over time. Memory forensics is another way we might detect this activity or the overall attack. The first place we can look, whether it's using a tool like Volatility or even some of the more traditional forensics kits, you can first obviously look at process listings. So if an executable payload has been created, the .exes, then we're very likely to see something like the PowerPoint.exe running on the system for an extended period of time. So then we might be able to compare that against a baseline we've taken before, or just reviewing the information around those binaries that are loaded, seeing what the image file was, maybe the file location like we talked about before, maybe it looks funny or something along those lines. Another part of our memory forensics is digging into the network connections that our processes are making. Especially when we're using shellcode that's specifically maybe loading a a modified Cobalt Strike beacon or interpreter that maybe hasn't been caught previously. Those things tend to call home somewhere, right? It's just how we have to be able to do our command and control efforts and everything. So often we'll see those in the network connections table. Sometimes, with EDR, obviously with the EDR bypass, maybe we don't see that. That's something we can compare later and say, hey, I've got this listing of domains or IPs that I'm looking at, but I'm not seeing that over here, and obviously it's something of interest. And it may be something that also points us back to knowing that maybe EDR bypass is occurring. Obviously, the other places to look would be our network forensics or SIM, and just seeing if some of that other data is there that we can compare against that maybe the EDR is missing, but we found them through these other means. With volatility, we can extract the DLLs and files that are within our memory capture. Once we've done that, obviously we can run tools like antivirus or a Yara scanner to identify sections of memory or those files that maybe were related to our attack. This is also a means to maybe identify the more advanced payloads that can be generated, not just the executables. So whether we're creating those DLLs that are being loaded, or potentially the W script code that's being used, or Excel payloads, this is another means of identifying all of those. Depending on the shell code that is placed into the loader by ScareCrow, the Malfind plugin from Volatility may be helpful. Reviewing the sections of memory that are marked with the execute and read-write capabilities, you can potentially identify that shell code or other activities that are occurring based on that shell code. With regard to disk forensics, we can still use our traditional approaches there. Often we time-bound our searches, so if we can identify information in our EDR or our memory forensics or maybe the network or SIM, we can start keying in on active files on disk that are maybe still there that haven't been deleted, or maybe we can look at NTFS journals to see, is there something that indicates that it was there but just recently deleted, and start just identifying those files. Besides those that are active, we can carve for binaries and DLLs and Excel documents and whatever else that the ScareCrow payload may have been generated as. Once we've identified those, we can do a lot of our traditional checks against files, whether that's their hashes and checking to see if it's out on VirusTotal, or checking the certificate chains to see if they're valid, or the certificate itself signing the binary is valid. We can check for odd locations where the binaries are stored. Again, the example of PowerPoint not normally running from the user's desktop folder. We can also run those carve files against our AV and Yara signatures to see if anything else pops. As we move away from the host and memory forensics and the EDR system, we can look at the network and see what is transpiring over the wire for some of the shell code that may be loaded in one of these EDR bypass loaders. First thing, obviously, one of the uses is for deploying a C2 agent. With that, we can still do things like beaconing activity monitoring or detection through a tool like Rita. We can look at the reputation of a domain or its age within various sources based on what we're seeing on the wire or our DNS logs, and just comparing that to see if it's something that looks like it's suspicious and maybe something we need to run back to and see what host that's occurring from, and then potentially digging further into EDR or wherever else. The other piece we look at is what's the size of the transfers coming from the host. So if we're seeing multiple gigabytes or in the worst case terabytes of data leaving to a location, we obviously need to take a look at that and see what's causing it, right? So we can dig back into that memory or EDR forensics. From there, we can also compare the IPs and domains that we see in the net flow, and just see, compare that against what we see in the EDR piece. So if we don't see that, example.com is showing up in traffic in the EDR, but we see a lot of it in, our network flow, then, we obviously have to compare our baselines and see what's going on. One final thing I'll leave you with is regard to Tradecraft. Many of the things that we've pointed out are basic uses of ScareCrow that maybe a less skilled attacker might employ. Things like generating the executable style payload, or using something like Meterpreter, or some easily detectable means. As an attacker shifts to a more skilled approach, using techniques that kind of slide the EDR bypass code in place, it may become much more difficult to detect. But still, detecting on the wire is probably our best bet. And a lot of these techniques may still work, because we often see attackers either screwing up because they don't know what they're doing, or oftentimes it's because they have a mission to complete and they only have a limited amount of time to do so. So just keep that in mind, that we often catch things based on mistakes made, but don't always expect those mistakes to be made. To summarize what we've discussed, we've gone over EDR bypass, what the technique is, and how ScareCrow creates payloads and loaders to handle that. We've gone through potential means of discovery, even disregarding that section of the EDR bypass code, looking for ways to find what else is going on in EDR within disk, memory, and network forensics as well. I'd like to thank Matthew Eidelberg for his work on ScareCrow and EDR bypass. Definitely check out his blog posts on Source Zero website. Also, in his talk, as mentioned previously, I'd also like to thank Ryan Boyle for his work in helping with this presentation. He provided a number of screenshots and the query for Carbon Black for searching for masquerading binaries. Definitely check out his talk as well, titled Open Source Forensic Threat Hunting. So I'd like to thank you for your time today. If you would like to reach out with any questions or comments, definitely check out the Source Zero Con Discord channels for any discussion there for this talk or others. You can also reach me on Twitter with my handle at Vrain_. Just let me know if you have any questions, and I'd be happy to talk with you.